Whoa! Oh, hi, I'm Lee. Welcome back to the channel. Fix It for Reselling. I picked up like 3 of these Behringer mixers. It's another one. I think I got 3 for 25 quid. Another one there. There's an X1204. This one's got issue with sticky buttons and stuff. Seems to turn on, but I need more testing on that one. But this is the most expensive one. That will probably be £200, I think, or yeah, 100 to 200 quid. We have got some. That feels broken, missing knobs and stuff. Seen better days. A few things are a bit bent. I wasn't going to film this. I've never looked at one of these before. Didn't really know how to test it. But first things first, let's just show you what it was doing. Right, let's just put some power into it. I'll turn the lights off so you can see it's a bit better. Flick the switch on. Right, press the power button. Basically lights up for a second and all goes off. Hope you can see that. Yeah, fan spins for a split second, but it's basically going into shutdown and protection mode. I've just started stripping this down by taking all the nuts and washers off of this bit, just to try and get the top off. So you have to take all these knobs off as well. I've just taken a photograph of the whole thing so I know what's what. But white, blue, red, black, and then just remembering what all these ones, you can't even see the ones down the bottom. Yeah, so wasn't bothered going to film this, but hey ho, let's give it a go. Let me go and get a pot for all these. Glued them in there. I'll show you this in a minute. I'll be very careful putting your hands anywhere near this. There's going to be high voltage in it still, probably. Right. Oh, so that's the back of that board. So basically just had that one connector in there. And then these grey wires were just being fed through this. It's got some hot glue on it. Let's just take off. Didn't need to take all these off at all. Ah, you live and learn. So, is it going to be something wrong with the power supply that's shutting it down? Or is there going to be something on that top board that's telling it to shut down, that's shorting or something? Presume it's got a short somewhere. Let's get it out of the way. Quick visual inspection and nothing is jumping out. But like I say, you need to be extra careful. This can have high voltage in there. Dee 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 dee. Right, so I just spotted. That's no good. What the hell? Oh, I've got you zoomed right in. Middle of the screen so you can spot it first. So someone's definitely been in here. That, which is actually touching that capacitor, and it's a ground screw. Oh, ground cable. So that was touching the leg of this capacitor. That's not going to help it, is it? There's nothing loose or rattling around. I reckon someone's probably been in it. Right, well, first things first, let's see if we can screw that down. Alright, let me just check that. Alright, that's in. Plugs on. Hit the power. Nope. Still shine down. Of course, it ain't going to be that simple, is it? Will it stay on? Just disconnected, probably won't even be able to tell because I've got no lights. No, fan spins and stops. So it's definitely going to be something in here, I would presume. Not sure what's in here, whether there's any output transistors going out to the main outputs on the back. Still not seeing much. Load of transistors on here. Let's check some of these transistors in here on diode mode. I haven't got a clue which one the base is yet. Is it marked? No, they couldn't be asked to mark it on the board. 0.4 and 0.4, 0.7. So again, 0.4, 0.8. So this is going to be a PNP. 0.4, 0.7. Is this the PMP? No, MPN. 0.4, 0.7. 0.4, 0.8. This one's the other way around. 0.4, 0.7. Yeah, so they all look good. Yeah, all these ends have got the diode reading one way and not the other. The other little transistors on the back seem fine. Couple over here. I didn't test. Bit of fluff. Right, so this board all seems to be testing good, as far as I can tell. Right, I was gonna give up on this. Didn't have a clue, but I thought I pulled a power supply out. Let's have a check at stuff. Why not? I did this off camera because, like I say, I was going to give up. But then I found something on here. We was going around. I was checking the bridge rectifier, which was all fine. We was going around because you got a few, transistors, MOSFETs or whatever they are down here. So, we was going around checking all these. Which one's the base? Not that one. Yeah, there. So transistors are all reading fine. I just started going around some of these diodes on here. Checking the diodes up there, 0.5. Hope you can see that over there. So 0.5, all reading okay. 0.38, 0.38, 0.3, 4.6, 4.6, 3.8 near enough. Yeah, 4.7. And a dead short. This diode is a dead short to ground, 0 volts. If we go to continuity, we'll get the beep, and even on ohms, yeah, 0.1. So we have a shorted out diode. Looking at the traces where this goes, we've just got one end that comes down to here, which is basically this capacitor on this side, and the other end is coming up to here, so it's going into the big transformer on this pin. So yeah, and then comes up through this big capacitor there, and also onto that pin, so into this inductor coil. I believe it's an inductor coil. So yeah, when you first took this out, be very careful. These are 400 volt caps probably. What are they? Oh no, they're 63 volt caps. But you have got some high voltage caps in here. So the first thing to do is just check the capacitors with your multimeter, because you're going to get shocked and possibly killed if one of them goes off and you touch it with your fingers. Right, so let's get this off the board. See, I might not need that. See if we can get this off the board and measure it out the board. Can I do both ends? Yep. Let's just tack it down one end just to hold it for me. Back into diode reading, and yep, that diode is short. We're not measuring a circuit now because we have one leg connected, so this leg's not going anywhere. So if it reads a short, that component is definitely shorted, because all it's going to is that cap, which is fine, and then down to like this other cap, which is reading fine. Let's see if we can show you what it reads on there. So it does say GG 3C. If I take this under the board, it actually tells you on the board underneath what it is. I did find the schematics for this as well. There's a GF1G, and if we look that up, that is a 400 volt 1 amp diode, which I don't have any of. But I have got a 1N5406. I can order these, they're only about 50p, but I just want to get this tested, see if it actually works before, you know, wasting money ordering stuff. So 1N5406. I think this is rated up to 500 or 1000 volts at about 3 amps. So it's more than this needs, which is fine just for testing. Let's get a nice blob of solder on there. Right, the net is on. Right, let's just put this back in its case and see what happens when we turn it on. Wait for the pops. Right, let's give it a quick flick on, see what happens. I'll turn this on now, flick that switch on, so I can just flick the plug switch quickly on and off. Here we go. 1, 2, 3, on, off. Right, with the fan spinned, or the fan spun. And it is shutting down again. Not quite sure what is going on there then. Alright, so here we have it back out again, and yeah, we are shorted. That's shorted that diode straight away. Let's make sure nothing else has gone. No, so everything else is open line, so nothing else has shorted on there while replacing that. Right, so I'm just going to have a quick look around here now, see if I can spot anything else, see if I can get the schematics for it. Right, so I have managed to find the schematics. I've circled where we are. This has got markings on it, it's D24. And this is basically the little circuit here. I mean, there's not much on it. That is D24, our GF1G. That is the one that's blowing. It says it's going out to DC+. That's our 450 volt cap on the other side. I've taken it off and checked it. And then that's basically all it is. It's going into this part of the transformer. And then into this chip, the TOP221P, which I presume is going to be a driver chip kind of thing, driving the current. On the other side of the transformer, it basically goes to V-aux. I've checked all these other diodes and resistors and capacitors around here. They all seem to be fine. So you've got D29, 30, 31. So you know, they're in the vicinity of where that diode was. There's D29, I think it says D30 and D31. We know they're alright because we've already checked all them. So yeah, these resistors are okay. And then finding out on the other side here, this is where our DC plus is. So basically this is our power in. Well, I'd say this is our power in, because this is our bridge rectifier here, which we've tested and is fine. So basically your AC's coming in either side of the bridge rectifier. So when it's on the minus wave, it will go out to your minus line. When it's on the plus wave, it will go out to there. And same with the other side. Basically turns your AC into DC. Got it going through an inductor. And then these few things, that goes off to the DC. So unless there's anything in this circuit that's over voltage in that, because then that goes into the transformer and out this side. So just maybe going to look around this circuit, because it does come down into this part as well. So maybe I'm just going to look up some of these resistors and everything else and just see if I can see anything else on the board. You know, it kind of like gives me some idea of what components are linking to this DC. So let's have a little look around the board. See, and there's that V-aux as well, which is what was on the other sheet that goes out here, V-aux. So it does kind of like come into this circuit here and can end up back in here. I don't know. It's very hard to read schematics unless you know what you're looking at. But, you know, it does give you an idea of the components and what component values are. Alright, let's have a little look around the board. See if I can spot anything. Come back to you if I find anything. I think I may have spotted something here. Give that a little... You can see where I'm wiping. You can probably spot what I'm looking at. Well, we know all these diodes are okay because we tested them before. I don't know if you can see up there. That one, I think it's got a hole in it. Yeah, that's rough. I think they've got a little hole and a resistor. But yeah, you can't like see that there. You can see we've got the same circuit. The same circuit down here. It's got a 222, 222, 122, 122. We've got a Zener diode, or just our normal diodes. And then we've got a 560. And that one up there, I presume, will be a 560 as well. So if there is 560, that's going to be a 56 ohm resistor. We're going up in the killer ohms and coming down. So 1, 2, 2. That would be 1, 2, and 2 zeros. So 1.2k. Oh, why is that reading shorted as well? What are these one down here? Oh, that one reads short. So yeah, 55.5 ohms is that one. So yeah, close enough to 56. What's this 222? Should be 2,200. Yep, 2,200. And this one, 2,200. So yeah, I'm not sure why these 1,220s are reading short. Interesting. Right, let's see if we can find them on the schematic. Right, I found them, but they're a million miles from everywhere else. See where this came in, and our DC goes to there. We had V-aux there, which is like down here. I found these resistors, 60, 61, 62, 63, all down here, and the diodes, which are going through the transformer for the plus V bus and the minus V bus. TR current, so it's got something to do with current. So maybe this part is linked to our diode in some way, and it is, you know, reverse charging the diodes. I do not know. Blowing the diode, maybe there's too much reverse voltage going through. So what one was blown? Which one was that? It was R60, wasn't it? So that is that one there. So yeah, so that tells us it's for 56. And the reason that 1.22k resistor is showing 0 ohms, or just over 0 ohms, is because it's going through that coil. So that coil is going to read in 0. So when you're measuring that, it will take the least path of resistance, so it will go through there because it's 0. It won't give you the reading. If I nudged it off the board, that would probably be reading correct. But because it's going through a diode here, we can measure these ones correctly, because it's not going back through this coil, because I think that diode's stopping it. So these 56s should be reading correctly, and the 2.2Ks, they're just on that line, so they're reading correctly. Okay, so we need to see if we can find a 56 ohm resistor somewhere, and we'll replace that one. Alright, so out of all my little spare boards, I cannot find a 56 ohm resistor, so I'm going to just I haven't even got a 56 in these. I've got 47 and 10, 57, close enough. I'm going to stick two of these together just for testing now. So I don't want to just be ordering parts for this if I can't fix it. Right, so let's get this one off first, and we'll show you what we're doing. Let's try heating up either side and pushing it off. Ooh. There we go, came off nice and easy. Right, so I'm just going to take one of these 47 ohm resistors, 10 ohm resistor. Right, and if I put two of these together, right, if I go to ohms now, this should be 57 ohms. So yeah, 56.9. Hopefully that's going to be close enough to 56 to be okay. Stick a blob of solder on there, hold it together, cut that off. A bit of heat shrink tubing, will that go over there? Yep. Just cut that a little bit longer than I need. Right. It should be out of the way and not short into anything. Right, let's throw this back in the chassis. Throw this back in the chassis and see what happens. Right, here we go. Plug it in the back. Make sure that switch is on. Plug it into the socket. Right, let's turn it on and see what happens. Okay, look good so far. Fan was spinning. Fan is still spinning. Nothing seems to be burning out yet. Fan is still spinning. Bit of a buzz or something coming from there, but it could be something to do with the coils or something. It's not quite tied down properly. Okay, let me wait for this to discharge a bit, and we'll connect the rest of the cables up and put the lid on and see what happens then. We have the top back on now to test it. Can't get the whole thing in shot. It's all close enough there. Right, let's turn it on. See what happens. Right, we're all lighting up. Still need to change this knob because it's all over the place. Does work there if we push it down. So it all seems to work. Let's see if the lights come on again when we use the switch. Ah, EQ in, that lights all them up. Yeah, there we go. Nice. Now unfortunately I haven't really got the proper connections and equipment to test it. Probably put something in the ins and see if something comes in the outs. Don't know, let me test that. Let me just shut this down. Whoa, shit! Whoa, shit! That's gonna smell.
What did you do?
Nothing. It was just on. Right, that's a catastrophic failure, everybody.
That's a bust.
That's a bust. It was playing out of there. I'm glad that was filming. We all love to see someone going up in smoke. What the hell was that? Catastrophic failure. That's like capacitors blowing up, that was. Right, we're all unplugged. Is that fresh liquid? That is fresh capacitor juice. So it must be a cap that's blown, is it? That connector is roughly around that position, which is just down here. I think this one's fucked, Nicola. I don't think we're getting any money from this one. Has our diode let go again? Yes, it has. That diode is shorted again. The resistor we changed is absolutely fine. Ah, there it is. Oh, how did I not spot that? So 450 cap has exploded. I don't know whether this cap here has exploded as well. I can see it now, all the mess down there. Why didn't no one point it out to me? Oh, and the legs have blown off our chip as well. What the hell? I think the amps in that diode I put on there was too high of rating, 3 amps I think it was. It should blow at 1. Now of course loads more damage. So there we go, that capacitor there has bulged, exploded. I don't know if you can see down in there, get some lights in there, you can see the legs have blown off that side of the chip. Oops. You can see it's all black against the side of that cap. I mean really it's only blown that one leg out the bottom. Totally cleared the hole. It's pin 5 and 6 blown off of there. Right, so that's our chip. Pin 5 and 6 have been blown off. So I think 5's the main one. 5's Looks like the drain. Maybe it was this chip that was... I checked the short, there was no shorts on that chip, I checked it. But these, all the other pins, 6, 7, 8, 1, 2 and 3, all come down to this negative rail, base rail. So we know that is constantly shorting. That has now blown, but I had that out of the board and it's fine. So that has had over 450 volts going through it to make that blow. Or could it be too much current as well? That being me putting a 3 amp in there, is that too much current in there? Don't know. There, and then that's our little cord that's next to everything for all the messes. So there you go, there you have it. That's what happens when you don't know what you're doing. You get explosions. It's the first time I've had a capacitor or something like that explode in front of me. But from my limited knowledge, I can't see what else is wrong with the circuit. I've tested most stuff, it looks okay. I don't know why the diode keeps failing. But I'm sure someone out there watching this will know and berate me in the comments. Berate away. So, you know, this is what happens if you don't know exactly what you're doing, and this is why electrics can be dangerous. You know, I've had the lid off that capacitor would have just like exploded up in the air, all the liquids would have come out. So yeah, playing with electronics can be dangerous, and only attempt this if you know what you're doing, and take this for a bit of fun, a bit of entertainment. Turn that light out, as I'm no expert, as you can see. But yeah, hope you enjoyed this one. You didn't learn anything, that's for sure. And please come back, see you in the next one, and hopefully nothing else explodes. Thanks for watching. Like, comment, subscribe. Do it now.